So all of this work with the triangles and now the unit circle and filling all that information in is leading to this. Having sine and cosine functions, and then in our next videos we'll talk about connecting it to our other trig functions, but for now just sine and cosine, and being able to evaluate these with an exact value and not using a calculator. And what we even want to do here is try to not use the unit circle. That unit circle, it's more about looking at the process. A lot of the memorization that I talk about in this class isn't so much the memorization of just looking at that circle and knowing what number goes where, but more that process of how do I get to that point, what kind of triangle is being formed, and what side lengths does that bring through to make that x and y coordinate. Now, if you have the brain that can just look at something and memorize, awesome, go for it. But what I'll talk about with these is kind of the process that I think about, which ties to the unit circle, but we don't need to draw the entire unit circle each time, and we don't even need to really refer to the unit circle each time if we understand those triangles and how they lie within that unit circle. So something we're going to tie back to is reference angles. In a way, really it's kind of the idea of creating our triangle with a reference angle. So if we think about our reference angles, so as a refresher, those are the angles that are formed with the terminal side in the x-axis. So with each of these, we're really focusing on how that line connects with our x-axis. And what we really want to imagine is the triangle being formed. So that would be that triangle there. If we're in the first quadrant, our x and y coordinates would both be positive, and we can just kind of work directly of evaluating those side lengths. Now, if we're in quadrant 2, what we're imagining is with our x-axis there, we're really focusing on this angle right here, or specifically this triangle being formed with that x-axis. So then looking at this coordinate, we're more focusing on this triangle and that x and y coordinate coming from the side lengths. Just over here, x is going to be negative and y will be positive. When we're in the third quadrant, we're focusing on this angle right here with our x-axis. Again, it's more of that triangle that we're seeing, and with that, to get this coordinate, thinking about x and y of the side lengths of that triangle, where both values will be negative. And then quadrant 4, same idea of this triangle being formed here and using those side lengths to get that coordinate. All right, so let's look at lots of examples. So, sine of 3 pi over 2. So what I do with these is I draw myself a sketch each time. Doesn't have to be perfect, just something to kind of help me visually. So 3 pi over 2, so that one's a common one. This will be down here. If you can't remember where it's landing, here's 1 pi over 2, so you'd have 1, 2, 3. Now that coordinate there, that's our unit circle, and that would be an x value of 0, y value of -1. Now, since we're looking at sine, I want to look at the y coordinate. So let me even make a note of that up above here, since it's been a little while since we talked about that. X is going to relate to our cosine of an angle, and y is going to relate to sine of an angle. So what's happening here is that we know our angle measurement, so that tells us where we're landing in terms of our unit circle. And then, so using that angle, we know where we landed. And then from there, we can get out our xy coordinate. And then all we need to know is which coordinate do we want? And we want the y coordinate. So that sine of 3 pi over 2, we could replace that with -1. That would be correct. If we wanted to double check this, what we could do is, let's see, we're in degree mode. I need to switch to radians because that's 3 pi over 2, and just sine of 3 pi divided by 2, and there's our -1. So you can use the calculator to confirm it. Once we get into our kind of messier fractions, it gets a little trickier, but I'll show you with that too. But with these ones that are landing at ones and zeros, you can check that pretty nicely here. All right, so that's the process that I go with these. I make a sketch of the unit circle, just think about the one angle where we want to land, and then use the coordinate to answer the question. All right, cosine of pi. I have my circle. And let's see, pi is here at 180 degrees, and that coordinate is a -1, 0. We're looking at cosine, which is the x-coordinate. So that right there is also equal to -1. If you wanted to check that, we go to that calculator and just go cosine of pi, and there's our -1. Perfect. So this is to show I'm not looking at the unit circle itself. I'm using the idea of the unit circle. It's definitely there, but we don't have to have it memorized necessarily to find these individual points. All right, sine of 2 pi. So 2 pi is at the same location as 0. So that would be right here at the point 1, 0. And we're looking at sine, which is our y-coordinate. So that right there is equal to 0. And -3 pi over 2. So if we have a negative angle, we can work with that. In that, we'll just move in the clockwise direction. So again, here's 1 pi over 2, 2 pi over 2, 3 pi over 2 in the negative direction. So that would land us right there, and then our coordinate is going to be 0, +1. And since we're looking at cosine, we want to use the x-coordinate. So that's just equal to 0. All right, now we're going to jump into the trickier ones, but I'll show you how to do these. So I'm going to draw a sketch of my unit circle. All right, 2 pi over 3. So what I do is I look at the denominator. So with that denominator of 3, I'm thinking about the thirds, which divided up our circle like this. If you looked at something similar in last week's lecture when we talked about angle measurements, and if I think of this as the starting as 0, I want 2 of these thirds. So we would go 1, 2. Which lands me right there. And now what I need is my coordinate. And this is where I think about the triangle. So with this triangle, I know I'm at a 60-degree angle here, and that's my 60, 30, 90, and I'm seeing my short side and long side. So the short side is going to be my x-coordinate, and it's negative. So that's going to be our -1/2. Our y-coordinate is the long side, and it's positive. That's going to be the √3 over 2. So what I did there is I had to first find where that angle measurement's landing, and then I'm visualizing that triangle that's there, and then just using direction of negative and positive to make sure my units are correct there. And then it's just the same. We're looking at sine, so I want that y-coordinate. So that is equal to √3 over 2. All right. 11 pi over 6. I'll talk about finding this angle in 2 different ways. So with the denominator of 6, I'm thinking about the one that has a lot of cuts to it. So that's the same as our 30-degree. It kind of does this-ish. I just need a sketch. Now, there's 2 ways of getting there. You can count around. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is right there. Another thing you can use is the fact that at this point is 12 pi over 6, so the idea of 2 pi, and we just need to go 1 back. That would find it as well. So this is our 30, 60, 90. I'm seeing the long side there and the short side there. So for the x coordinate, we have the long side and it's positive. So that's going to be the root 3 over 2. And then for the short side, that's our 1/2, and that's going to be negative. And then I want to look at cosine, which is the x coordinate. Again, using that angle measurement to see where we land, and then using that triangle in there. 7 pi over 6. Ooh, sorry, I just need to draw this circle first. It's a little more tricky. All right. So here I'm thinking about the 6th. And I'm doing this kind of long here. You might find some shorter ways of doing this, or you're just going to get used to the fact that 7 pi over 6 is right here. You don't need to draw all those lines. This is just our first time making these connections, so I'm going into a lot of detail. And if you need more detail, just email me and I can help even further. But what we would do is divide it up with 6 and go 1, 2, 3, 4, 5, 6, and there's our 7. Now this is our 30, 60, 90. I'm seeing the long side along the x-axis, short side along the y-axis, and both are going to be negative. So for x, we'll have that long side, negative root 3 over 2, short side, negative 1/2. And we want sine, which is the y-coordinate. All right, 7 pi over 4. So this one is using our fourths. And I know I'm saying fourths, and you're like, but she's dividing the circle up into eighths. The fourths is really coming in here because that's pi, and we're dividing that pi up into fourths, so it is overall eighths of the circle. But that's because our circle is kind of 2 pi. All right, so I want 7 of those, so we could count around, or we could use the fact that at 0 is also 2 pi, so we just need to go back 1. That should land us right here. Now, this is our triangle where the side lengths are both root 2 over 2. So all I need to do is get the symbols correct. So x is going to be positive and y is going to be negative. And we're looking at cosine, which is the x coordinate. So that's going to be equal to a positive root 2 over 2. Now, checking this answer with a calculator, I know I've done a few of these without checking with the calculator, but what this would look like, so you'd have cosine of 7 pi over 4, and you get that out, which, cool, that's a great number right there. But we want these exact values, so to check that it does match your exact value, just plug in root 2 over 2. And you see you do, in fact, have the same number. It's just with the unit circle, we're able to get these exact values out. All right, 2 more. Because the more practice we get, the better with these. All right, negative 11 pi over 6. So moving in the negative direction. Again, I'm thinking about these sixths. And we want to go negative, so that's going to be in the clockwise direction. And we're going to need 11 of them, which is going to bring us right there. So there's our 30, 60, 90 with our long side along the x-axis and short side along the y-axis. So x is going to be positive root 3 over 2, and y is going to be positive 1/2. We're looking at sine, so we want the y-coordinate. And our last one here is going to be, let's see, we're dealing with fourths here. So I just imagine cutting up my circle like that. And let's see, it's negative, so we're going clockwise. We're going to go 1, 2, 3. So we're here. The Triangle is the 45-45, so I know I have the same side lengths, and since we're in the third quadrant, they will both be negative. So cosine, even though these are exactly the same, cosine is the x-coordinate, so that's going to be a negative root 2 over 2. So with the unit circle, with these triangles, what we're getting at is for these specific angles that are coming through on the unit circle, we can make these exact substitutions. So if we're solving something and come across this cosine of negative 3 pi over 4, where this gets stuck because it's function notation, again, we have this name of a function and we're showing an angle where we know the measurement of the angle, but what we want to do is replace that with a number so that whatever we're doing, we can keep solving. And what we need is that ratio of side lengths, which cosine represents, and that ratio of side lengths is giving us this value, and then just depending on where our angle lands in terms of the quadrant determines the positive or negative nature of that number. So we're getting at this point where we want to make these exact value substitutions, and it all comes from this unit circle.